Chapter 14.2 is about partial derivatives.
We have discussed taking derivative of many kind of functions.
With one independent variable and how to interpret the results of derivatives. We now consider functions that have two or more independent variables. In the previous sections, an example of a company producing surfboards was discussed. The cost function for a company producing only the standard board is C of x, so this function only have x as the variables. The second one, and the derivative of this cost function gives the marginal cost function C pi of x is 70. Since the marginal cost is constant, $70 is the change in the cost for 1 unit increase in production regardless of the output level. But then we are now going to see the company producing two types of surfboards, a standard model and a competition model. The cost function is going to have both x and y as the variable like here. If we try to take the derivative of the cost function with respect to x, treating y as a constant, then we will write this notation, c with the subscript of x comma y. If we are trying to take the derivative of the cost function with respect to y, holding x as constant, the result of the derivative is denoted to c with the subscript y, xy. These derivatives are as follows. So we're going to do some example quickly before we move on. This is what we showed you last time, right? We said that the subscript x means we are taking partial derivative with respect to x, which treat y as a constant. So just quickly review what we did last time. What do we get for the first one? If we are treating x as variable and y as constant. So the first one would be what? This is variable. How do you take x cubed? That's going to be 3x squared. So it's going to be what? Because this is 9 times, this is 3x squared. And then be careful with the next part. We're treating y as constant, so it's going to be 4y. You bring it down, right? And then taking the derivative of x squared will give me 2x, and y is constant, so this whole term is constant, so this will turn into 0. So that's what we did last time. We got 27x squared plus 8xy. Is it okay? If we're taking the derivative with respect to x, treating y as constant. The next one is treating y as variable and x as constant. Then this whole term is constant, right? So it's going to become just 0. And then for the second term, again, 4 and x squared are constant. I'm taking the derivative of y, so we get what? This whole thing is constant. Because you cannot get rid of the number if it's attached to a variable that is still there, okay? And then the last part, we are treating y as variable, so this is going to be 13 times 2y. So we're going to end up with 4x squared plus 26y. This is the basic example, and then the notation can be written as what we just did, f with the subscript of x and f of subscript of y, or you may see this like backward d kind of squiggly one, d dx. The bottom part meaning you are taking the derivative with respect to x, okay? And sometimes people may do shortcut like that also. So those three are all acceptable notation for this type of questions. Let's flip to the back page. We're going to do another basic example. This one have x, y, and z. Ready? X, y, and z. The first one, we are taking the derivative with respect to what? X. So we are looking at x and treating x as variable, So the first term would be what? X will turn into 1. And then what do I do with this? They are constant attached to the x, so we just bring it with them. So pretend this is like 2 or 10 or something like that, right? So it's going to be 10 times 1, right? And the second term, both y and z are treated as constants, so this whole thing is going to turn into 0. Are we okay? So this would be y squared z cubed for the first one. Second one, we are taking it and treating y as the variable. So if the y is variable, when you take that derivative, it's going to turn into 2y. And then what do I do with the rest of them? Leave it, bring it down here as constant. Are we okay? And then the second term, we are treating y as variable, the other two as constants. The y taking derivative is going to give me what? A 1 for the y part. How about the rest of them? They are my constant here, right? Multiply to the 1. So when we simplify that, we're going to have 2xyz cubed plus 3z. Are we okay with that? Going to need some practice.
For the partial derivative,
The last one is treating z as a variable. Z is a variable. If I take derivative of that, we get what? 3z squared. How about the rest of them? They are constant, so attached to this. And then adding, so again, z is the variable. When you take derivative, this will turn into 1. And the rest of them, constant, so attached to this. After you simplify this, we are going to have 3xy squared z squared plus 3y, right? Are we okay with this? It's a little bit confusing at the beginning, but hopefully after a little bit practice, you can do a basic one like that. And we also want you to be able to plug in numbers, okay? This is example number 3. This is your function, have both x and y. We are taking this derivative with respect to, so the x part will become 2x. How about the y part? This is constant attached to it, minus the x will turn into 1, and then 5y squared is the constant part, right? So together we have 2xy squared minus 5y squared. Are we okay? So that is taking the derivative with respect to the x. But if they want to plug in number, this is your x value, this is your y value, right? Just use the answer. You have 2 times 4 times 1 square, subtracting 5, 1 square. So this will give me
5 and then 3.
Okay, so that's the answer. Are we okay? So definitely you need this for the exam. So I'm going to double check when we do the review on Tuesday. I may do some work problem. It's pretty much the same, but this one give you a revenue function and a cost functions, but they ask for profit function. So you have to get a profit function first and then take the derivative with respect to the x and on the y, and then plug in number. That's pretty much it, just in the work problem form. And the last one, anytime they ask you the two product is competitive or complementary, if after you plug in the number, both of them are greater than 0, this is supposed to mean competitive. If both of them are less than 0, meaning they get a negative number, they are complementary. If they don't have matching one, so if one is positive, one is negative, then it's neither. So that's everything in 14.2. I'm going to sneak in more example as time allow, okay? But I have to make sure you have 13.2 also.